the signs that be silent. The signs that be silent. The signs that be silent.
Good evening to everyone. We see people are still arriving, but welcome. I'll wait one more minute of awkward pausing and then we will get started. Well, good evening to everybody and welcome to the December 2021 edition of SETI Talks. My name is Simon Steele. I'm the Senior Director of Education and Outreach at the SETI Institute. The SETI Institute has been holding monthly talks on cutting-edge topics of astronomy and the search for life in the universe for over 10 years. And this month, we're coming live from New Orleans, Louisiana, and the 2021 annual meeting of the American Geophysical Union. So after years of waiting, an armada of spacecraft are heading to Venus. In June, NASA approved not one, but two new missions named VERITAS and DAVINCI to our closest planetary neighbor. And ESA, the European Space Agency, quickly followed suit and approved its own mission called EnVision. Venus has been a forgotten planet for too long, especially if we compare the number of missions to those that have been sent to Mars, the next planet out from the sun, from the Earth. These missions to Venus will not only answer key questions about the planet, but on comparative planetary science and the science of comparing planets and their evolution over time. One of the fundamental questions since we visited in the 1960s is why Venus and Earth appear so different. Venus could have been a twin planet, but instead it's become a hellish wasteland with a surface temperature hot enough to melt lead. Venus's atmosphere does have traces of water today, but the history of water is unclear. Did it used to have an ocean? And if so, was it lost? Is there still water deep within the interior of the planet? Answers to these questions will give us clues on the past habitability of Venus and perhaps the future habitability of our own world. Our host on site tonight is Dr. Frank Marchis, Senior Planetary Astronomer at the SETI Institute, and he'll be introducing our two special guests. We also welcome your questions. Please type them into the Q&A function on Zoom or comment on Facebook and YouTube. And Rebecca and I will be behind the scenes to pass on these questions to the panelists at the end. But please hold off on the questions until our moderator gives you the nod. We probably won't get to them all, but we'll do our best to get to as many as we can. So without further ado, it's over to Frank Marchis, live from New Orleans.
Thank you very much, Simon. Welcome, everybody. So we are at the AGU meeting, the American Geophysical Union, and I recorded a video so our viewers can see a bit what is those kind of conference and what we do. Maybe Lee, you can play this video.
Hi, hello. Welcome to the AGU. So this is the hall of the AGU with all the poster session. I cannot tell you how many there is per day, but I will say it's more than 2,000 of them. Look at that.
Thank you, Lee.
So here we're talking a lot about Mars, because today is a Mars day. But tomorrow we'll be talking about Venus mostly.
Thank you. So that was a video that I grabbed quickly yesterday at the poster session of the AGU. It's a gigantic building here. We have, I don't know, I think 10,000 or 15,000 researchers, but we are very lucky because we have two very special guests to talk to us about Venus today. So let me introduce them first. On my far right here, we have Dr. Sue Brecker. Hi, Sue, how are you?
I'm doing great.
So Sue is a senior research scientist at the Jet Propulsion Laboratory and Caltech Institute of Technology. She has an interesting background because her research focuses on volcanism, tectonic geodynamics of Venus and Mars. In fact, you are involved in the InSight mission of Mars, which
Yes.
is right now on the surface of Mars, but you also you're also the principal investigator of the newly selected mission called VERITAS. And you're going to tell us everything about VERITAS, which will
Absolutely.
explore Venus. I would just mention as well that Sue has received numerous awards. She was elected at the International Academy of Astronautics in 2015, and she received the NASA Exceptional Achievement in Science Award in 2011 for discovering evidence of the recent volcanic activity on Venus. So I'm assuming we are going to talk about volcanoes, right?
Yes, please.
Okay. And nearby me on the right, we have a colleague of mine. We know each other for more than 15 years. I would say 20
So, yes.
years.
I would say
probably.
yes.
So Thomas Whitman, how are you?
I'm good. Thank you. Thank you
Good.
for welcoming us here.
So Thomas is a senior research scientist at Paris Observatory at the Louisiana Laboratory. He's also an senior associate professor at University of Versailles Saint-Quentin. Thomas you can call yourself a planetary scientist, atmospherist. You study atmosphere essentially, right? Atmosphere of every planet, even trans-Neptunian objects.
We did that together.
We did that
months
together.
ago.
And Thomas is also a deputy lead scientist of EnVision, a mission recently selected by ESA to explore Venus as part of the Cosmic Vision program. So I know you to prepare some kind of slide to discuss a bit, to present,
Very
to
briefly,
introduce
yes.
briefly.
Very briefly.
So let's go through that right away. So I'm gonna show them here. Sue, I think you want to start, right?
Yes, so this is an artist's view of a volcano on Venus. We have evidence from Venus Express that it could be active, the research that you mentioned, and that's a possible subduction zone in the foreground. So anyway, just the name of the mission there and some art to start us off. Yeah, so these are some of the questions that we're going to study with VERITAS and be followed up by DaVinci and EnVision. But some of our key questions are, do we have evidence for essentially continents like we have on the Earth? Continents on the Earth formed when massive amounts of basalt, like the oceanic crust, melted in the presence of water. So we want to find out if there's the same chemical signature for these plateaus on Venus, which would tell us about water at or near the surface of Venus. So that's a really big question to answer. Next is about the volcanic history of Venus. If you ever picked up something about Venus, you probably read that it resurfaced 500 million years ago or so. But I actually don't believe that. I actually think that resurfacing has been going on in a steady manner.
Okay.
And that's a really big question to understand in terms of what's going on inside the planet and how volcanism has affected the atmosphere over time. So that's a question we're going to answer. And then, yeah, we're going to study this process of possible subduction on Venus. And again, that's really important to understand because we believe that subduction is the first step in making plate tectonics on the Earth. And that happened billions of years ago on the Earth, so we don't have a lot of data to constrain and distinguish between different models. So we want to study subduction on a planet where there isn't yet plate tectonics and try to understand how did subduction start on Venus. And then lastly, we're going to find out about heat coming out of the interior from studying the topography and the gravity. So, you know, these are all questions that are super important for Venus, but they also inform how rocky planets evolve and what shapes their habitability over time.
Yeah, we're gonna discuss that in more details later on.
Yeah. Yeah, so then I just have a slide about the mission itself. We have just 2 instruments. We have a radar and a gravity and a spectrometer and a gravity science experiment. And so the radar is going to acquire a bunch of different data sets, global topography at 2 orders of magnitude better, imaging at an order of magnitude better. And it's going to make the first maps of surface deformation.
Okay.
As well as look for changes on the surface from from the Magellan mission 30 years ago to VERITAS 10 years from now. And then our spectrometer is going to do a bunch of different measurement. Well, it takes one measurement, but we derive different information about the surface rock type. We're going to be looking for these so-called felsic rocks like continents that has a past signature of water. And we're going to be looking at volcanoes. We're going to look for the thermal signature of active ones. We're going to look for a chemical signature of recent ones. And, I think we're going to learn some totally unexpected things about rock type. and then lastly, we have a gravity science investigation, which uses our telecom system and the changes in the Doppler signal of the telecom system to get at surface density, subsurface density, and we'll be constraining the size of the core, whether it's fully liquid or partially solid in the interior, and look at the spin rate of the planet. So those are our top level measurements.
Okay, excellent. That's interesting. And this mission will be launched?
We expect to launch at the end of 2027.
Okay. And arrival 2029?
Yes, we will start taking science data. Actually, we arrive in 28, and then we do some air braking and so forth, and we start taking data in 29.
Okay, good. We're gonna go through that too, probably. Thomas, you...
Yes, as a follow-up to what Sue said, yes, obviously the surface investigations are not the big issue because we have relied on Magellan data for almost 30 years now, and we really need to go in forward in a new generation of interferometric radars, which are the only way to observe Venus from orbit, because it's covered with 20 kilometers thick of clouds. And so all orbiter missions to Venus in the coming century will be radar missions. Okay. So it's obvious that we need a radar orbiter, whether it's an orbiter from Europe or from the US. And so that's also a way to complement what will be addressed by VERITAS. And we also want to capture, in addition to what was said, all the current activity or volcanic activity at Venus, and especially by probing the atmosphere. And in Europe, we have this Venus Express mission, which has flown between 2006 and 2014, which have given Europe a sort of a lead on exploring Venus atmosphere. And so we combine those 2 heritages, one from the Magellan and radar missions in the past, and NASA is providing the key instrument of that mission, which is the INSAR radar, and also Venus Express, where we will try to capture and to study how rare gases or trace gases reflect possible current activities, especially volcanic activity, whether in the troposphere or in the upper atmosphere. And so ESA is, as you can see, Europe is a continent. So ESA is a collection of, is not only a space agency, but it's a collection of space agencies working together and forming, defining priorities for their science, national science communities. So it's quite a complicated process. And so we went through this, and we had, of course, a stiff competition like all space projects. And we succeeded because this was really science driven. And the fact that Venus is obviously not an easy destination, especially something where we will never land a human being, obviously, which was a reason why we didn't explore Venus in the recent decades, is now, I would say, a driver of going there, because we want to understand why these 2 planets as similar as the Earth and Venus could be, because they are formed with the same elements in the same regions of the inner solar system. They have the same, approximately the same mass, the same size, the same diameter. And so we want to know what went wrong with Venus, and not knowing today what has driven those
The
two
difference.
different itineraries or evolutions means we are not sure how to explain why Earth became habitable indeed. And so that understanding those, variety of possible evolutions of one Earth mass planet at one AU of its parent star, we are, I think, at the beginning of this exploration now. And the Venus program we are leading with Dr. Smykar and others is only the beginning of this new venture in the inner solar system.
You want to say something more on the slide? Or?
Yeah, I don't want to spend too much time, but yeah, the EnVision is, as I said, sort of a combination of the best of what Europe can provide in terms of payload instruments and science teams across member states of ESA. And so they have combined their forces and efforts and expertises to provide this proposal, and which was in the end successful this year. So we are very happy of that.
I am glad to see that there is an American contribution to the mission
it's
as well.
It's really important. And Sue, you may
can I, if I could just add, so we have European contributions to VERITAS as well.
Okay.
We have our spectrometer is from Germany, and parts of our radar are from Italy, and parts of our telecom are from Italy and from France. So it's a very interconnected set of missions.
Yes.
Yeah, interesting. Okay, you want to see the next slide? Or you
yeah, we can move on. Yes. And so, Sue, you may take the lead for this one.
Well, yeah, so people aren't used to thinking about Venus and habitability, perhaps, but it's an interesting observation. We can't yet say fact, but a hypothesis that Venus is actually the first habitable planet in our solar system, because in the history of our solar system, the sun started out less luminous than it is today. So all of the planets were originally receiving, less energy from the sun. And so, Mercury has always been too close. It's just too much radiation at the surface. But Venus was very likely the first planet that had liquid water at the surface. So this diagram shows this. It shows, the history of water over the duration of the solar system for the rocky bodies, our terrestrial planets. And so you can see Earth on the top, has always had geologic activity in orange, and water to the present day. And Venus, we believe is active until the present day. We're going to be studying that in much greater detail. And we think it probably had liquid water at the surface before Earth. And we don't really know how long that water has remained on the surface.
So we don't know really the duration of this.
Exactly. Certainly none today, but maybe until a billion years ago, we these missions want to investigate this. And so, yeah, you can see that those conditions for habitability have been present on those two, twin planets for a lot of the solar system history. And that's super exciting, even though Venus is no place for life today on the surface.
Good. I think we have a good introduction here. I have a lot of questions, of course, to ask, but I want to make sure we talk first about a third mission briefly. So if one of you can tell us a bit about DAVINCI, please.
Yes. Oh, well, yeah. Well, DAVINCI is well, maybe I should let Sue describe this, because this is also a successful NASA mission in the Discovery class program. It was announced, and the selection was announced at the same second
time?
as VERITAS was announced. So I think the agencies now are really trying to make sure the science community is behind those projects and those selections, and that's very important. And this is what made, I think, this success across the Atlantic, because obviously all the executives on both sides understood that there was really a community ready to address those issues now. And so that makes probably an explanation. And DAVINCI is a totally different kind of a mission. It's a probe that will descend in situ in the atmosphere to study those isotopic ratios that are extremely important measurements for understanding the past history of the planet and the way the atmosphere outgassed from the inner structures or mantle, also whether it was a primary atmosphere or secondary atmosphere, and also all the current day activities and composition of the atmosphere that we can only measure from in situ.
From in
measurements.
situ.
So there are other of
Yeah,
course,
because
other
your
science goals.
missions are orbiters.
Yes.
They will orbit Venus for years, I would say, multiple years,
Yes.
and take measurements and take spectroscopy measurements, radar measurements, and do experiments like gravitational experiments.
Yes.
My second question, that's for you, Sue. Can we talk about phosphine on Venus? Can we just discuss this and then we're done with that, so we don't have questions on this topic?
Well, I am not super knowledgeable about phosphine, but it's it's an exciting possibility, right? I mean, there's a lot of controversy. We don't even, have agreement as to whether it's been detected. So maybe it's been detected. And then the question is, what does it mean? There are different possible interpretations. So, I think it's very exciting that we possibly have, the idea that there could be life in the clouds, right? And time will tell. Things will pan out one way or another as to whether it's really there and what does it really mean. So, it drives excitement about that possibility, and that's a good thing.
Okay, so let's talk specifically about your missions. I mean, I want to make sure that our viewers understand that Venus has been explored in the past. The Russian explored Venus. They even land something on Venus, the Venera landers, right?
The Soviet Union.
The Soviet Union, sorry. Yes, thank you for correcting me on this one. And we also launched missions in orbiters. So why a new mission? What will be the benefit of observing Venus again for 5 years with orbiters?
Yeah. Why? I mean, the technology has entirely changed. Those missions were designed in the 20th century for more than 40 years ago, when the technology was not, what it is today. And we have this ability with the new technologies of, think of the satellites orbiting the Earth and doing environmental studies of, landslides, which are technologies we didn't have in the past. And it's the same for Venus. We have totally new science that will emerge from those new scales of exploration and study of the surface of Venus. Think of Mars. What we knew of Mars in the at the times of the Viking orbiters in the 1970s. The resolution of the images from orbit were approximately the same as we have today with Magellan in our studies. And so at every time we improved the scale of our measurements by a factor of 1 magnitude, maybe going from 100 meters to 10 meters, then 10 meters to 1 meter, we discover new phenomena, new science, new couplings between the surface and the lower atmosphere on Mars, for instance. Or we can see those rims of the crater which are eroded, or which are having those structures that we didn't suspect from other scales. So new scales bring new science, and so we have a totally unknown, planet sitting next door, just next to Earth, which we almost don't know anything about, and we have everything needs to be done.
And if I could just add, when we went to when we took data for the topography of Venus in the 90s, that resolution was better than we had for the Earth. But now, we have better topographic resolution for all the other planets, for Mercury, Mars, the Moon. Even Phobos has better topography data than we have for Venus now. So we can't really do those comparative planetology studies with such, outdated data. So we really need to go back and put Venus on the same plane as all of the other rocky bodies in our solar system.
Yeah, I heard that we know more on Mars, in fact, that we know Earth, because we cannot map the depth of the ocean with the same resolution as Mars. So where is Venus in this?
Yes, when we include the oceans, that's right. Yeah, that's absolutely right.
Well,
And-
no,
and-
but even for the
even for the
the
continents,
continents
for
in
the
the
continents,
90s,
in
we
the
did not
90s,
have
yes.
the topography data.
I
Yeah,
think-
but now.
But I think, Frank, you are mentioning that today, even today, when we have
Yeah.
reached the resolution we have. Yes, that's true. And at some time in this discussion, I'm sure we'll discuss what makes those four inner bodies different. And
That's
why
in
did
fact
they
my next
evolve.
question.
I think I
Mhm.
can read
So
your
is it-
mind.
maybe you can ask yourself your own questions. then.
I mean,
So
this-
why
I mean,
those
they-
why those four planets,
I mean,
which are not formed at the same time, are so different?
and I'm just following up what you just said, is that we need to explore data which have the same spatial resolution, which have so we can actually compare those processes, those geophysical processes, mantle properties, surface compositions, and so if we do not have any of those data for Venus, we cannot compare those four
Ah.
bodies. So
Just
that's
to
the argument.
clarify, this is a very interesting point. You can have very good resolution data of Mars, and then you have very poor resolution, blurry observation of Venus. You will not be able to truly compare those two planets.
That's the
And that's
point.
the point
Yeah, that's the
here.
point we try to
Okay.
raise. Yes.
So
Mm.
why are they so different? Do we have some kind of hypothesis that you will be able to confirm or not with those missions? This is more than 5 minutes answer, but
No,
Can
but
you
we,
give me
we
just a
might have, as you mentioned earlier, that subduction might be a sort of a possible driver of initiating plate tectonics.
Mhm.
Maybe it's a temporary stall. Maybe it will resume one day. We don't know. Maybe it's currently that we have volcanic eruptions on Venus. We don't have the resolution to observe them, but maybe there are active volcanoes that we will be able to observe. And the combination of all our instruments will allow to track, volcanogenic gases or sulfur dioxide molecules that are or water vapor, which are, if that might trace that kind of activity.
so
as
what
well.
do you think?
Well, one hypothesis that people have put forward is that Venus is dry in the interior. And that's kind of like in a way, an outdated idea in a sense, because that was an idea that people put forward in the 90s. And, we've learned so much more about water in the interior of the Earth, in the water that comes from comets versus from asteroids. People used to think most of Earth's, atmosphere and oceans came from comets.
Mhm.
But now we have data, these isotope data that Thomas was mentioning. And now we realize that most of the water does not come from comets. At planets, they start out with the water in the interior that's lost into the atmosphere via volcanism. And so, we'll be able to look for possible water still coming out of the deep interior of Venus. And you need to have significant amounts to let it, be buoyant enough to get into the dense atmosphere of Venus. So, if we could observe that, that would really completely put to bed that hypothesis that Venus is dry in the interior.
Mhm.
And people have said, oh, well, maybe there was a giant impact that dried out Venus. And it's possible, but we don't have any ability to test that until we go with these missions. And so that's one hypothesis that we expect to really be able to test. And so that's one idea of why Venus and Earth have kind of evolved differently, but we don't have the data to say if it's correct or not.
I do remember my classes when I was doing my master 20 years ago, where those hypotheses were mentioned.
Mhm.
And it's true that it's shocking that 20 years later, we still don't have an
Yeah.
answer to this.
Yeah, exactly.
So good for the students of the future. They will maybe have textbook which will be very different.
Oh,
Exactly.
absolutely.
And we will know why there is no plate tectonic on Venus, or maybe we missed it. So I want to stop a bit about the science and talk a bit more some personal things about yourself. How did you get involved in those missions? Can you tell us the story a bit, like summarize, of course, but how did you get this interest in Venus, first of all, and why, and how do you get this position in this mission?
You start.
Okay.
You answer first.
I
I think I know what you will say.
maybe you should
About-
answer.
Venus, Massachusetts.
Oh.
No, you want to
Uh,
mention the city where your
Oh.
father was born?
Thomas wants me to say that it's my destiny.
Okay, go ahead. Let's talk about the destiny.
Yeah.
I love it.
My father was born in Venus, Pennsylvania.
Okay.
Yeah, and I was born the year the first spacecraft flew by Venus just recently.
Like, yeah, very recently.
Yeah,
Okay.
yeah, quite a while ago. And but in terms of my scientific interest, yeah, I happened to go to a college university that had planetary science, and that got me interested in planetary science. And then I did my PhD work, you know, just before the Magellan mission. So I got my PhD around the time of the Magellan mission, and I got to, you know, be there at JPL when, you know, images were coming in, and, you know, be in a room with a whole bunch of amazing geologists and geophysicists from around the world, and, you know, be able to put out ideas and, you know, just be completely blown away by what we saw on the surface of Venus. So you know, even though we haven't had data for decades, I've never lost my passion for Venus, because it is our twin. It does things we learn about the Earth. We can say, well, what about Venus? You know, it gives us another place to test our hypotheses. So
Yeah, I will say that people who study exoplanet don't like Venus because we always have this amazing theory of habitability and so on, and then comes someone who know about a bit more about Venus and will tell us, well, what about Venus? And then say, oh yeah, it doesn't work.
Yes,
Exactly.
Maybe all the exo-Earths are, you know, more exo-Venuses. That would be a terrible thing. And
So what about you, Thomas?
Yeah, I would like to say first that Venus is the brightest object in the sky after the moon and the sun, of course.
You can see it right now, by the way.
You can see that this hour, yes. And it has always struck me. I was an amateur astronomer all my life. I mean, since I was a child, I had a little telescope, and I was always wondering why this bright object is so poorly explored by man, and why do we focus our efforts on other planets while it's right there? And I'm also a lot of interest. My parents are my father was a historian, and I was always interested in history and history of science. And Venus has a particular, you know, role, and is reproduced and studied by all civilizations and represented as a goddess or a god in all parts of the world. And it's also one of the most ancient, or the most ancient artifacts in museums of tablets of Assyrian tablets describe Venus motions and ephemeris and so on. So it's really part of human cultural heritage and human history, and that's always something that has struck me, that we lack so many information on. As a scientist, this resonates with my own interest. And why did I study Venus in my career? This is also the second part of the question. I cannot say why. I knew it was a difficult task because it was not a popular subject among, you know, for PhD students or for early career scientists. But I was particularly interested in the fact that, yeah, there was not much more interest in that planet at that time. And I think finding the right arguments to have the proposals accepted to observe with a ground-based telescope, for instance, was a driver of my, you know, I always like challenges. I like hard things and hard work. So it was, you know, sometimes probably one of the reasons. And yes, we never discussed that in the past.
So just before we go back to the science, so what's the main challenge for someone like you to have this role in a mission like that? What is the most difficult part of the job so far?
Well, lots of difficulties. One, just, you know, persevering,
Yes.
because you know, I've been trying to get this mission selected for, you know, a dozen years easily, and the opportunities to propose don't come very often. So you know, I guess keeping the faith, and also, you know, I mean, honestly, you know, I think I've learned over time to be able to convey the excitement of Venus to people who, you know, don't study it all the time. And so, getting better at conveying that excitement and message, to the public as well as to NASA headquarters. I didn't take a degree in, public communications, and I'm used to speaking to scientists. So I really had to learn to communicate better.
Good.
Mhm.
And what about you, Thomas?
How did I turn up?
No, what's the biggest challenge you have so far being involved in this mission?
I think it's important to listen to everyone. I mean, in such a complex project, and you saw how ESA is a complex collection of space agencies, but it's also the same when you have 20 scientists around the table. They all have their views on how much of Venus you should explore to address a specific science objective in our mission. And so we have sometimes to make trade-offs and to make, balanced statements and judgments, and people have to agree in the end. Otherwise, the project will not move forward. So forming a team and making sure the team is working as a team is I think the key for success of those projects. And I was happy to realize that people felt listened to, and everyone collaborated in the way that if we want to succeed, we have to agree in the end. And so that's at the end of the day, we have to all agree around the table. And that was my main effort to make this project a success, especially as at the time NASA went into the project and provided the main instrument. Then we had to merge the two cultures of NASA priorities, a way of prioritize its actions and support its efforts, and the way ESA works with many layers of decision-making layers. And so we have also to talk to people and make sure they understand their philosophy and their way of working.
So that's an important point for viewers. Science is not only writing codes and making calculation in front of the computer. A big component of science, it's also to listen to people, to argue, to convince, and to promote an idea or a project or a mission. And I will say that you two, over my 20 years, I've seen you promoting your missions, and I'm very impressed, because you have been like promoting Venus no matter what. That's it, and it pays off, obviously. So where were you when this announcement was done that you got the mission?
I was in my kitchen.
We were in lockdown, both sides. I think we were both in lockdown.
We were both in lockdown in your kitchen?
Yes,
Yeah.
I was at home as well.
Oh,
yeah, it was, I think 4 a.m, so I was close to my coffee pot.
Okay, let's go back to the science. I just want to remind our viewers that we will take soon some questions. Time is flying with you. It's already 40 minutes into this conversation. So I'm gonna take like 10 more minutes to ask science questions, so you can answer shortly. So we'll probably have more questions later from the people. But there is a big mystery on Venus. I mean, that's something that I read a lot about over the years, this mysterious UV absorber. So can you, one of you, take the time to explain what this is and how your mission will finally solve this mystery, hopefully?
Yes, I can say a few words on that. Yes, because it's when you look at Venus, it's uniformly white. I mean, from space. But when you look at Venus in the UV spectrum, you can see some contrasts in the clouds, and those contrasts are moving fast, and they are tracing the motion of the atmosphere, which is in super rotation around the planet. The planet has a retrograde motion of 243 days. Backwards, it's rotating westward, but the atmosphere has a 4 days super rotation. And those markings in the clouds are key to understanding that dynamical motion. But those markings are short-lived. They move, they change shape, and they disappear and they reappear. So their dynamics is very poorly understood. We don't know if they are chemically related to some chemical reaction within the clouds, or whether they are driven by particles or whatever those particles are. They are driven by convection within the clouds. We don't know. So we need to explore those properties with one of the spectrographs of EnVision will map those motions, but also those UV spectrum to track and detect possible molecular signatures in them. There have been many hypotheses in the past for the last 40
Can you
years.
give us a few hypotheses? Because I read papers for that.
Yeah, there are many. Some have argued it could be some meteoritic origin with iron sulfides. An acid was named the croconic acid. It was an acidic form of carbon monoxide, or etc. So people did tests in laboratories to try to reproduce those spectrum. The Russian probes that went down into the atmosphere had some clues. And I worked during my thesis on one of the instruments on board one of the Vega landers, and we had some UV signature of that element, but it was at such a low resolution that it was not conclusive. And so it's still a mystery what it is and why it is formed, why is it associated with the upper clouds. And so we are looking forward to understanding more about those.
So this mission, your mission, will have a spectrograph.
Yes.
So basically, you're going to be able to analyze the light coming from this area and get a spectrum, so see the profile.
Yes.
And hopefully compare with some lab measurements. Or...
Exactly. And DaVinci, because we are also discussing how our three missions are complementary, and DaVinci will also probe those regions, and hopefully we'll be able to image the exact location where DaVinci will enter the clouds, so we have some clear view whether we are.
Synchronize the missions so you can
No, they won't be synchronized, unfortunately, but at least we will have some context imaging, I'm sure. And so we'll be able to know whether DaVinci penetrated the clouds in a region which is particularly rich in UV absorption or not. So we will have some clues on that.
Nice. That's that's an interesting mystery. I mean, at the AGU, we had an entire session on UV spectroscopy, and there is so many mysteries.
It's interesting because
in this field,
CO2 is absorbing the more distant UV than SO2. So we know that SO2 is absorbing in UV, and then we have this absorber which is slightly almost in the visible light, in the blue part of the spectrum. So this is actually why Venus looks a bit yellowish in the sky. When you look at Venus in the sky, you know this pale yellow color is due to this unknown absorber. So you can see the absorber with your eyes.
Oh, that's good. I didn't know that.
Neither.
All right. So I have a question for you, another mystery,
Okay.
a famous one, volcanoes. Is there a volcano? Yes or no? What type of volcanic activity? What kind of lava? I mean, I have a ton of questions about volcano. So tell us a bit, where are we now with the volcanoes on Venus?
Yeah, so Venus is in some regards the most volcanic planet. 80% of the surface is covered with volcanic features, and we're just starting to get information that tells us about what volcanoes may be active today. The Venus Express mission that Thomas mentioned, almost accidentally took data for the surface and around 1 micron. The spectrometer wasn't originally designed to do that, and we were very fortunate that it was able to. And in that part of the spectrum around 1 micron, you can actually see through the clouds to the surface. And so using that information, we were able to see that some volcanic areas had what seemed to be quite it's high emissivity, which to first order it corresponds to very dark rocks, and less so in the plains. And so like if you've ever been so lucky as to see a lava flow freshly erupted on the surface in Hawaii, it comes out this incredibly beautiful silver shiny flow, and then within an hour it's like it started to turn black. And that's because the atmosphere is interacting with that new chemical surface. They're not in equilibrium. And so similarly on Venus, when a flow erupts on the surface, it's not in chemical equilibrium with the atmosphere. And so we know that it starts to interact. We're not entirely sure how rapidly it happens, because there's very little water in the atmosphere, so it probably doesn't happen so rapidly on Venus. So, but we have evidence that there are chemically unweathered flows. So recent, is that a year? Is that a million years? We're trying to understand that, but but there's evidence for recent volcanism. Just more and more factors point towards activity on the surface. So we're going to be investigating that and trying to understand, really what's the origin of those volcanic features, and look for many more of them.
So concretely, what instruments will be able to see through the clouds, and are you going to be able to see multiple wavelengths from the surface?
We see like 6 channels, but they're all close to 1 micron, because that's the only area where we can penetrate through the clouds. And so that's what we call the VEM spectrometer, Venus emissivity mapper, and you call it VEM spec what?
Yeah, M with an M for mapper as well.
Mapper, yeah.
Yes, I'll mention after that
Yeah.
we have the same instrument on board EnVision.
Yeah, so we use the topography that we'll be acquiring to help take out the surface temperature variations that are due just to altitude, and then really hope to determine the amount of iron in the rocks on the surface, and that will help us understand the process of weathering of this chemical interaction, and hopefully how we'll be able to determine how recent the activity is. In my wildest dreams, we'll see differences between, the spectra that we take on VERITAS and the spectra that were taken from Venus Express, and then changes to EnVision.
Exactly.
So, if things are really changing on the timescale of years, we should be able to see that.
So we'll see volcanoes in action and surface changes due to volcanic activity on Venus, maybe.
Exactly.
Maybe.
It can be a change of emissivity. It can be even a slight temperature change will be measured by this instrument, also by our radar. We have this way of measuring the temperature of the ground using the radar signal as well. The fact that we have those instruments on both missions will allow us to track down those possible activity.
So I'm assuming you
regions.
discussed before when you designed those instruments.
No, actually, we didn't. Oh no, I mean, it's a complicated story, but
it's complicated.
So many people, told us that Venus is not, a priority of agencies. So if we have one mission, we will be lucky. And so we try to make sure, because this instrument is so important that it was mandatory to have it on any orbiter, whatever orbiter will fly. But now we have the 2 missions selected over a decade. We'll be able to measure those slight variations in latitude, in longitude, according to the land mass. If we see, an activity somewhere, it would be frustrating not to be able to follow it after the end of the VERITAS mission. So EnVision will be there to pick up and take over after 2035, between the second part of the decade after the decade will be EnVision time.
Well, I have one more question, and then I just received the question we got from our viewers, and there is like 8 of them. So I'll just one more question from me.
Of course.
Can you tell us, one of you, what is exactly this radio science experiment and what you're expecting to be able to derive from that?
It's very important, and Sue will speak about it first.
Sure. So the one thing that we can derive is the size and state of the core. And an easy way to visualize this is if you think you have imagine you have a raw egg and a cooked egg, and you put them on the table and you spin them, right? They spin differently, right? Because the raw egg, it sloshes around. So that's really what we do for measuring core size and state. We determine how much it wobbles and how the rate at which it wobbles and the degree to which it wobbles. And that will give us information about the very interior of the planet. So we're excited to get that information. And in terms of understanding exoplanets and habitability and water loss, a big mystery is, why doesn't Venus have a dynamo? Why is there no magnetic field active on Venus? It should have one. Crazy places have magnetic fields. Mercury has a magnetic field. Some of the icy moons, they have magnetic fields. Why not Venus? It should be so much like the Earth, but it doesn't have a magnetic field. And, we're not measuring that directly, but getting the size and state of the core will give us some first order information about what's the composition, because when we know the size, we get a lot better information about the actual composition. And so that's, is there something different? What's going on the inside of Venus? So we're very excited to learn about that.
Good.
And both our missions will be low orbit, like the
Okay.
ISS around the Earth. It's maybe 200 or to 300 or 400 kilometers, a bit higher for EnVision. So as you know, the gravity field is not uniform, and we have when we have a large landmass on Earth like Himalaya mountains, the satellites would go a bit down because there is not only the mountain but also the the
root.
the root of the mountain, which is
A significant mass, basically.
which is allowing the continent to float on the mantle. And so the presence of this underlying mass is visible on the trajectory of the spacecraft. And so it will be measurable also with our two spacecrafts. And so we'll be able to measure what we call the isostatic compensation, the fact that large land masses are compensated by this underlying structure or not. If the mantle is very rigid and has low viscosity for some reason, it will also tell us a lot about the upper mantle structure as well. But radio science has also an atmospheric goal, so this is why I'm picking up on what was said, because the reflection of the radio signal from the spacecraft to Earth within the atmosphere is also a way to measure the H2SO4, the sulfuric acid droplets of the clouds, and whether they are made of gas or liquid form or a combination of both. And so the different reflection in different wavelengths of this radio signal will tell us a lot about the fine and detailed structure of the clouds, which is quite unknown. And that will also be a good complement of what Da Vinci will find in one single location. With EnVision, we'll have vertical profiles of H2SO4 vapor every time the spacecraft is passing behind the planet seen from Earth. And so that will be very frequent, approximately as many times as the sun sets and rises from the ISS. So it will be a powerful tool to study the clouds.
Yeah, and with VERITAS as well.
And VERITAS can do that as well. Yes, absolutely.
That's a lot of data.
Yes. We'll need students and maybe a large community, and that's our intention, is to make this community grow.
Yeah.
And we'll make sure that scientists of all generations, are able to address those new fantastic times ahead, and having those three missions combined.
Okay, well, you already have a lot of people interested in Venus because we have a lot of questions. So what we're gonna do is to answer as shortly as very shortly to this question, sorry. And I'm going to address the question to one of you. But if you don't want to take it, you say, "Oh, Thomas will be better to be doing that." Okay, so our first question from I don't know the name. So, does the technology needed to do a sample return mission from Venus exist today? If not, why not?
Okay, we both have something to say about that.
Okay, Thomas.
It doesn't have to be the surface. It could be the atmosphere. Bringing back an atmospheric sample to Earth would also bring some ideas. And we had that. I just wanted to mention that. But of course, we are not even able to bring back samples from Mars. So it's really a complicated thing. And as you know, might be possible at the end of this decade.
Why is it more complicated to get a sample from Venus than from Mars?
Because you need a launch system. Okay. You need to launch back to Earth, and
it's a big
Venus gravity is really high, and so you need a Cap Canaveral thing.
Yeah, I mean, you need to build Cap Canaveral on the surface of Venus to be able to bring back a sample.
Where the surface temperature is 500 Celsius.
Exactly.
Details.
So it's unlikely we'll have a sample return from Venus in the coming years. Yeah, that's obvious. But the atmosphere might be a possibility.
You wanted to talk about the atmosphere sample, right? Yeah.
Oh, no, I think that's also a value, although I would love to have a rock from the surface of Venus, but the atmosphere would also be a value for sure.
So I heard there was some kind of private mission project to get samples or to get a probe into the atmosphere. Is that still the case?
I think, well, I don't know if it's going to be returned, but yeah, I understand there's work developing a private mission to go and study the atmosphere with the hope of trying to discover whether or not there could be life in the clouds. but
Alright.
I don't think they bring the sample back as far as I understand.
Okay.
That's my understanding as well. Yes.
Okay, so question number 2. Thinking of the major objectives of these 3 missions, what will be the significance to planetary science? And thinking along the lines of the decadal survey, if successful, what will be the next steps for each of the objectives? That's a long question. Sue, you want to
Yeah.
take this one?
Sounds like a paragraph.
Sure, that there are so many questions in the decadal survey that which will make, will really almost, significantly answer, there's the great thing about doing missions is that when you answer some questions, new ones arise. But in terms of what we already anticipate wanting to study, we want to learn more about the interior. We'd love to have some ability to do seismology in some way, either from orbit or from a balloon. And it's better resolution. We're going to get fantastically better resolution, but people still want to know more. We'd love to have, Da Vinci goes through the atmosphere and studies the atmosphere, but they aren't going to last on the surface. And, just as the landers that the Soviet Union sent a long time ago, the instruments that we could send to the surface to even last for several hours, would give us vastly improved geochemical information, to be able to really look at, the details of the composition, the details of what is, what are the minerals that are weathering to, from fresh basalt to these weathered minerals, and how long does that take? And, isotopic compositions that could tell us more things about core formation and interior volatiles. So, we'd love to have geochemical information from the surface. There's that's a kind of an obvious next step of things that we'd love to do, and lots of other, missions that one can conceive of as well. Studying loss from the atmosphere of the ionosphere, the magnetosphere. There are questions there too. So I could have a long answer, but I'll
Okay.
just stop
No,
there.
no, no. I think it's perfect.
So I have a third question, since we can move on this one. This one is an easy answer. How does Venus magnetic field differ from Earth? And if there is a difference, might it have contributed in any way to Venus evolution over time? I say it was easy. It's not an easy question.
No, it's not an easy question.
Go
but
ahead.
maybe I can start on Sue will pick up. There is some remnant induced magnetic field in the upper atmosphere, because there are some ionized particles that move around Venus, and there is some measurements that can be done. But that's of course not coming from the planet itself, the solid planet, I mean. So that's a big question. There is no dynamo inside Venus, because we don't know, and there is no explanation basically why. There are some hypotheses, and this is obviously something that must be taken into account to explain the long-term evolution of Venus, because there is some interactions with the upper atmosphere. The escape rates of ions and light species in the upper atmosphere are more inclined to be sent to space or lost to space, or less inclined if there is a magnetic field. But this is something that maybe Sue can comment on that as well for the long-term evolution of Venus. It's so under constraint. I mean, we have many models to explain what volcanism, what magnetism could reflect, but I mean, it's so under constraint that it's unlikely we'll have some answers in the coming years.
Yeah, I mean, the simple hypothesis used to be that, the more massive a planet there is, the more it hangs onto its atmosphere, and the presence of a magnetic field also protects the atmosphere from erosion by solar wind. But recent data from Venus, from Mars, from the Earth, that theory goes out the window, because they're all losing oxygen at the same rate. So what's with that? We really don't understand that. And so, by understanding, what's gone on, did Venus, could it have had a magnetic field in the past? That's a really important question for understanding how volatiles, water in particular, have been lost from the atmosphere.
Mhm.
So, you know, we really need to understand that piece of the puzzle to understand the overall evolution of its atmosphere.
Good. Another question about the moon. Is there any relationship between the current environment of Venus and the lack of a moon around the planet? It's like a quiz.
Well,
huh?
no, we have. I mean, in the Paris Observatory has an expert on the field, because we know that the dynamics of the Venus would have been totally different if there was a satellite, because of the axis, spin axis coupling between the two. So it might have a possible effect, long-term effect on the habitability of Venus, but that's something that's so related to other issues that I won't comment on that right now. But Sue, you want to make
Well,
your own view on that?
I mean, you know, I think I mentioned before that some people have proposed that, you know, there was some huge impact in the past that could have dried out the interior, but then it doesn't have a moon. So, you know, that kind of makes that hypothesis challenged. So, yeah, I mean, if it, the original question was if it had a moon, how would it have been different?
Yeah.
Yeah. So it definitely, yeah, the orbit definitely would have been different, but in terms of the habitability, I'm not sure how it would have affected that, honestly. It's an interesting question.
So those are questions we will be able to answer maybe in 20 years after those missions. Another question, very technical. I don't know. I think there is a lot of people from the AGU who are watching this today. Why are felsic rocks a signature of water? Does Mars have felsic rocks?
You can do that.
So yes, Mars has felsic rocks. Even
Yes.
the moon has felsic rocks. But the difference is that they do not have consonant scale outcrops of felsic rocks. Because, you know, on the Earth, we know that we had to have massive amounts of melting in the presence, melting of basalt in the presence of water to get these continents. And you can get, you know, partial fractionation in a magma chamber that can give you felsic rocks, but not on that scale. There's just not enough rock to melt to give you, you know, a plateau that's a couple thousand kilometers across. It's not possible without water. That's why we're pointing towards the presence of felsic rocks on that scale as being an indicator of water.
Yeah. Okay, this is a question for you. Are there any observations the two missions, VERITAS and EnVision, can do in collaboration? You already discussed that. Maybe you can remind us a bit.
I was just going to say that we have this ability from VERITAS and EnVision to map those felsic rocks, and see how they have evolved, and to make sure we have this signature of minerals formed in a water-rich or volatile-rich environment.
Can I ask a very technical question? How you differentiate felsic rock to mafic rock?
It has lower iron. Felsic rock has lower iron and more silica. Now it has some other variations too, but that's what we'll be looking for.
So the spectrum will have a different profile at 1 micron.
Yes,
specifically.
We have spectral elements. It's not. It's more like a it has several filters in a various wavelengths. So, and we cover all these infrared window that Sue was describing earlier, next to 1 micron, 1.18 microns, and this is where we will have this signature of the nature, whether those minerals were formed in a water-rich or volatile-rich environment, and we are looking forward to that. It's the same difference as granites and basalts, for instance, on Earth.
Okay. Okay, another one. I like this one. Let me phrase it.
So you are smiling looking at the question, so I'm a bit
will
scared.
Any of the radar mapping instruments in those missions be able to measure any significant Venus quakes or any potential existing continental drift?
That's two different things, but
maybe you can answer to one and you answer to the other one.
Well, seismometer, I mean, we were speaking of the radio science goals for studying whether the state of the core and the size of the core, etc. So we need seismometers. This is how the Earth's core was discovered, whether it was a solid inner core. So that was discovered in the early 20th century using seismometry signals. So we don't have this ability to do seismometry on the ground. We have hopes for long-term, ground landers that would be equipped with one seismometer like InSight on Mars, but this is really for the distant future. There are some other techniques that would make use of the dense atmosphere, and large earthquakes might trigger waves in the atmosphere that might be detected in some with some types of instruments from orbit also. So we are also thinking of that, signatures of large earthquakes, but that's all for earthquakes. But there was another part of the question.
But I mean, with repeat pass interferometry, we'll look for surface deformation.
Yes.
So that it's not the same as recording an earthquake, but it's seeing evidence of faulting
after
or
effect, basically.
volcanism. Yeah, yeah. So
so we're talking about cracks or
Think of a
collapse of a
magma
part of
chamber. Imagine a subsurface magma chamber expanding, even by a few maybe sub-centimeter scale is detectable with VERITAS interferometry mode. So it's a very powerful mode.
I want to
detect
talk about
those.
that.
Yeah,
I
or
forgot
Or
this
fractures
question.
or tectonic.
Okay, that's a question that
activity.
is not here, but I had. So you will have an interferometer mode that allows you to see the very good accuracy, as you mentioned, centimeter scale, right?
Yes.
And I heard that the public will be able to contribute to this. Can you tell us a bit about that?
Yeah, so it's a very precious resource because we can only acquire deformation, look for deformation in maybe at most a couple dozen locations. And so we want to get all the input that we can from the community as to what's the best target, because we want to choose them as wisely as we can. And yeah, we haven't quite structured it yet, but eventually we'll be asking for community input as to which targets are the most likely to be active on Venus.
Nice. This is very cool. I like the fact that you're going to involve a larger community, definitely. Okay, another question. I don't understand this question, so let's see. What are the top 3 things, CO2 level, O2 level, methane level, etc., you would like to discover?
Well, we know the amount of gases in the atmosphere. We have known those what we call the mixing ratios with respect to CO2, which is the dominant gas in the atmosphere. 96% of the atmosphere is made of CO2 on Venus. So it's what's interesting is the second order measurements, and that's probably what the question asks. What can we learn of improving the margin of error on these mixing ratios? The main point is whether they are variable in longitude, in latitude, in local time with respect to the sun, for instance. And so that will tell us a lot about the chemical reactions in the atmosphere, the nature of those components, what triggers those reactions, whether they are driven by dynamics, whether gases are transported from the lower atmosphere to the upper atmosphere through the clouds. So those measurements are not an information by themselves, but their variation, spatially or temporal variations, give us a lot of information on the processes within the atmosphere. And with EnVision in particular, we will cover the atmosphere over a period of 4 Earth years in a way it has never been covered. And so we track down all those small scale and both in temporal and spatial scale processes and variations of those different gases.
Okay, so it means that if, for instance, you have the suspicion of an active volcano, will you be able to target this area to see some kind of change in the composition at a very localized, the fumarole or something?
I mean, we
Exactly.
map, we create
constantly map,
global,
yes, exactly.
global maps constantly, yeah. But yeah, I mean, I will be completely thrilled if we are able to observe water coming out of a volcano, because it will address this first order question of, is the interior of Venus still water rich?
Still water rich.
Yeah, yeah.
All right. I have one question which is not scientific, but I like this question because it's I mean, we discuss a lot about what has been published in the past about Venus, and I mean, you mentioned those missions, and you mentioned that will make progress. So if someone wants to learn right now, a student want to prepare himself or herself to do a PhD about Venus, what should this person read now? to have kind of an overlook of what we know about Venus.
Well, there are a lot of books out, and we're working on a new book
Exactly,
about
yes.
Venus
Okay.
right now.
We have, yes, we have a new, well, spring, I won't name the editors. Yes.
Evolution through time, Venus evolution through time. It probably won't be ready right away.
Only
but,
next year, but we are trying to assemble, yes, the state of the art, experts to describe what's known and what remains to be addressed, and what will be constrained by those future missions that we need to for constraining our current models.
And there was the Venus 3 book that came out
Yes.
just recently. That's also a good place to start, and that has many references, so they can follow up on their particular interests.
Yes.
So that's one resource.
That's at the University of Arizona Press.
Yeah.
No, not Venus 3, that Cambridge.
No, that
Is it Cambridge? Maybe
yeah, Springer, I think. isn't it?
Springer.
Yeah.
Springer.
We will put the link. I
Yes,
will
the
put the
link.
link on the
Please,
yeah,
yes.
don't worry. It's the end of the day for all of us, so we're a bit tired. Yeah, I think we went through all the questions. In fact, I'm impressed.
The two first volumes were University of Arizona Press, but the third one was a different editor.
Okay.
That's why I was.
Thank you for the
searching for it.
clarification.
I was,
Thomas is like still thinking about it.
Yeah, I'm trying to be right.
Okay, so I have a final question for you, for both of you. The same one. How the study of Venus can inform us on the past, present, or the future of Earth? Who want to take this one first?
Okay.
So,
Oh, you can start.
either
sure.
way.
Oh, well, either way. Well, it's the fact that we have a planet sitting next to ours, which have almost the same, shape, size, distance to the sun, and composition and atmosphere properties, it's a mystery. And as I said earlier today, so long as we are not able to explain why those two planets diverged in their history, it will be very hard to understand what made Earth habitable as it is now, and as we know it today. And our missions will address part of those questions. What made Venus and Earth so different, and at which time of their history they diverged? Whether was that in their DNA, I would say, in the early stages of when the planets were formed, or did they evolve in parallel for billions of years, and the differences came much later in their history? So we don't know that. We are not able to respond that. And many of our measurements will address this question of what made those planets so different. So yes, studying Venus will tell us a lot, about what made Earth habitable as we know it today.
What about you, Sue?
Well, I like to refer to Venus as, the once and future Earth, because, the one area that I'm super interested in is trying to understand how did Earth develop plate tectonics, and why does Venus lack plate tectonics? And many people have pointed out that Venus is in some way a good analogy for early Earth, because all planets, they start out hot. They have a hot lithosphere, that strong outer shell. And Venus today, because of climate change, has a hot lithosphere. So it's possible that processes that happened billions of years ago on the Earth, starting of subduction, starting of plate tectonics, the formation of continents, we don't have very much data for the Earth about these time periods, which happened so early on. And so we can go to Venus and study possibly subduction happening today, understand, are these continents, what allowed them to form on Venus? So we can, go to Venus today and study potentially early Earth. And, of course, we are very interested in studying climate change here on Earth. And of course, I'm not saying that we will ever end up like Venus, but there are many processes in the atmosphere of Venus that inform our understanding of our own atmosphere and the climate on Earth the reactions. I remember hearing someone propose, oh, well, we should introduce sulfur particles into the upper atmosphere of Earth in order to slow down climate change. And, somebody studying the atmosphere of Venus said, no, that's not going to work, because we see those particles in the upper atmosphere of Venus and they just photo dissociate. So they're not going to hang around. So, there are these very close parallels between processes on Earth and Venus, which is, what makes studying Venus so fascinating, and, will be so informative for understanding not only our own planet, but other rocky planets.
All right. Well, thank you very much to both of you. That
Thank
was
you.
a fascinating conversation on Venus. Frankly, today has been an eye-opening for me. I learned a lot today. I'm glad we had the opportunity to have this conversation, and I hope we are going to hear more about Venus thanks to your missions in the future. So,
well, thanks a lot for inviting us, and thanks for the audience for their great questions. And we're happy to contribute to this, outreach effort.
okay.
Thanks for the chance to talk about my favorite planet.
Yeah, and don't forget, this is the SETI Institute, so you can write your comments, questions at the bottom of our pages on YouTube and Facebook and so on. And we will take the time to read them and to answer to them. And if I cannot answer to them, I will basically ask Thomas and Sue to tell me how to do it. Simon, you back?
I'm back. Yes,
Yeah.
thank you very much. I'm just fascinating. The old Venera images of the surface of Venus are still some of the most haunting and beautiful images in astronomy, I think. So thank you, Sue. Thank you, Thomas. And thank you, Frank. We'll let you go to bed soon. I know you're 3 hours ahead of us. Thank you to the crew behind the scenes, Rebecca, Jasmine, Lee, and Beth, who have been controlling the internet for us and making sure that things have worked well. We have had viewers from around the world, and I just made a note, this isn't an exhaustive list, but people from Hawaii, Colombia, Belgium, Italy, Oklahoma, Poland, Manchester in the UK, Canada, Ohio, India, San Jose, Greece, New Mexico, Brazil, Guatemala, and West Virginia, to name a large but not a complete list of where people are watching in from. So that is absolutely amazing. Our special guests today will receive the very exclusive and very costly and well-made SETI mugs and patches, and we will send those items to you at some point. So we'll get those out. They are beautiful and incredibly useful. A reminder to everybody that the SETI Institute is a non-profit research and education institute. These events are brought to you at no cost to you, but we are always very, very grateful for donations. You can go to our website to learn more about that. We did receive a Facebook donations from Amber, thank you very much, and some Facebook stars from Ron, Freddie, Klaus, and Amber. So thank you so much for making those contributions while you watch. If you're interested in sponsoring a future SETI Talks, that is an opportunity for you. You can go to the email address development@seti.org, and Rebecca can help you look into that if you would like to sponsor one of these events in the future. Definitely check out the website, SETI.org, for future SETI Talks and events, and you can sign up for our monthly newsletter, which will talk about all of the science that's going on at the Institute. So I'm going to stop there and wrap up by saying thank you all for tuning in. It's wonderful, amazing talk. And on behalf of everyone at the SETI Institute, we hope you have a peaceful and enjoyable holiday season, and we look forward to seeing you again in 2022. Thank you so much and good night.
Bye.
Thank you.